Hey there. Today we're treating complex numbers. When we talk about complex numbers, let's first do some small tutorials first. From our normal algebraic examples we have 2 plus 3 plus 4 plus 7. Let's bring this into bracket. We know that 2 plus 3 is 5 plus 4 plus 7 is 11. And you have these two, 16. But know that with the complex numbers, these are normal real number questions. Are you getting it? And you have in these integers, complex numbers, real numbers, and a whole lot. Are you getting it? And not denoted by certain letters. But know that with the complex numbers have to do with we have A plus B. What is A in this case? What is B? And what is I? Know that the A here is a real number component. Same for the B. And the I is equal to the square root of -1. That makes, try punching this on a calculator. Root of -1. You have error. Are you getting it? So that's the complex number. So you have a way of deriving stuff in math and science. Are you getting it? So they found a way. That's the complex numbers. I know that the complex numbers have algebraic forms. Are you following? And using the algebraic representation, the usual operation on the complex number can be performed by the following. That is 1. Addition. Z1 plus Z2 is equal to, let's say, A1 B1I plus A2 B2I. What makes the BI the complex part is due to the I attached to it. Hopefully they are multiplying. So once we have this, we have what we did over here, the real numbers. So like plus like, hopefully. So then row A1 plus row A2 plus B1 plus B2 multiplying the I. Or one can say AI plus A1 A1 plus A2 plus B1I plus B2I. They're all having the same answer. Are you following? And know that with this you have the multiplication part. Multiplication. That one we have Z1 times Z2, which is what? Let's bring X and Y. X1 plus Y1 I times let's try solving this. We know that from multiplication we multiply that of this one. Let's say X multiplies this, the Y multiplies this, and the same Y1I multiplies this. Are you following? So let's go. X1, X2, the same X plus, because it's positive, x1 y2 I plus, let's come to the y. Let's bring the row number first. Are you getting it? So y x2 y1 I, and there's an exception over here. You treat that one the powers of the number of I. That's when I multiplies I, you have -1. Put this in mind. So we have y1 y2. So now this is the answer, but let's sort them out. Real is to real and imaginary to imaginary. Or I. And note that with the same multiplication, we have row numbers multiplying the complex components. So let's make a new, let's say alpha. It's multiplying a set of complex numbers, and this complex number is 1I. This is what we are multiplying with, the row number multiplying the complex number. This is the complex number. Let me make it hyphen. So once we have alpha times z, it is what? Alpha x plus 1I. That is alpha x plus alpha y I. Following. In the same instance, this for 1, 2. Let's have it for alpha, then z1 and z2. Where z1 and z2 are complex numbers, but different. They are different in nature. Are you getting it? That is, this can be 1 plus 2I, and this can be 3 plus 4I. Are you getting it? So we have alpha z1 plus alpha z2, and let's go to the third one. Let's say alpha 1 times alpha 2 times z. We have it to be alpha 1 times alpha 2 alpha z, if you are correct. So let's go for the last one. Alpha 1 plus alpha 2, all multiplying the complex number. So we have it to be alpha 1z plus alpha 2z. Now let's go to subtraction if you are done with addition and multiplication. So number 3. Subtraction. So now I have z1 minus what? z2. So x1 plus x1I minus x2 plus y2I. Someone will ask him, why won't we go to numbers? You will come to the numbers very soon. Are you getting it? So we have this to be, I don't know, like the addition, real minus real, and imaginary minus imaginary. Are you getting it? You're not multiplying, but you're sorting them out. So 2 plus y2I. Are you following? Once this is done, in the multiplication part, I said there are powers of the number of I. So let's treat that one and go up in solving questions. Powers of the number I. So with the powers, earlier I said that I is equal to root of -1. I know that from indices, every number raised to the power 0 is equal to what? 1. And we have I raised to the power 1. That is root of -1, which is equal to I. Are you following? So when I with this I are talking about, even when you talk about I is the root of -1. So let's try squaring the I. That is what? All squared. The square will cancel this, so they have what? -1. So when we square the I, now do you know the reason why we got -1? So let's go to the cube, I cube. We'll be solving the I cube after this commercial break. You're welcome back from the commercial break. So the I cubed, we have I squared times the I. So indices are used to getting, when you add the index, you get a 3. 2 plus 1 is equal to 3. So you have this to be -1 times I, so it's -I. So let's go up to I raised to the power 4. Let's try solving this. We pick the 3 times I. That's -I times I. You know that I squared is what? -1. So we have this to be 1. Are you getting it? So let's go to the I to raise the power 5. So we have I raised to the power 4 times I, which is 1 times I. That is what? I, definitely. Let's go to higher index. Let's say I times 10, I raised to the power 10. You know that I raised to the power 5 times I raised to the power 5. 5 plus 5 is equal to 10. That is I times I, which is equal to I squared, where I squared is what? -1. You know, because I have solved it right now. Are you getting it? So let's keep on solving the powers, because in some certain problems you encounter in solving some certain questions, you must apply these powers of numbers of the I. So let's go to I raised to the power 32. With 32, how can I get 32? Should I start with 5, 5, 5, 5, 5? No. So we have a 5 raised to the power 6 times, because 5 times 6 is 30, and raised to the power 2. Because it's in bracket, we just take what's inside. Are you getting it? So let's have this 5. 5 is what? 5 is I. So I raised to the power 6 times I raised to the power what? 2. That's -1. And I raised to the power 6 here times what? -1. We have this to be, so I raised to the power 3 times 3 times -1. I raised to the power 3 is -I. So negative times negative times negative is negative, because negative times negative is positive. So we have I squared times negative I, and I squared is what? Negative 1. Negative 1 times negative 1, you have 1. How are you getting it? This video, please give us a share and please subscribe.